Right now, TRAPPIST-1 is still burning through a quantum process that should have stopped millions of years ago, and astronomers at the European Southern Observatory have no way to predict when it fails. This star exists at the absolute limit of what physics permits, and what they found inside its core is the part nobody is telling you. TRAPPIST-1 is a red dwarf. It sits 39 light-years away, close enough that we've mapped its planets in detail, far enough that we can never reach it. It is ancient, billions of years old, and it is tiny, 8 times less massive than our Sun, so small and so cold that by every classical rule of physics it should not be fusing hydrogen at all. The protons in its core don't have enough energy to touch each other. The temperatures are too low, the pressure is too weak. A star this size should be a drifting, dark cinder, but it isn't. The only reason TRAPPIST-1 burns at all is quantum tunneling. That is the process where a particle, a proton, passes through an energy barrier it physically doesn't have enough energy to cross. By every classical law, that is impossible. You cannot walk through a wall, you cannot leap something taller than your reach, but at the quantum scale the rules break. A proton can simply appear on the other side. No permission, no energy borrowed, nothing. This happens billions of times per second inside every burning star in the universe. Without it, our Sun goes dark tomorrow. Without it, every star in the Milky Way dies in an instant. We've known about it for decades. We've built it into every stellar model we have. But TRAPPIST-1 is tunneling at a rate that doesn't match the model, and the deviation is not small enough to ignore. The first team to flag this was at Liege, using spectral data from the SBECULOOS telescopes, instruments built specifically to watch TRAPPIST-1. They were hunting for atmospheric signatures on its planets. What they found instead was a consistent, repeating deviation in the star's luminosity curve. Their tunneling rate equations cannot account for it. Harvard Center for Astrophysics ran the same data through their own models. Same result. The star is producing slightly more energy than a star this mass, this temperature, this age should produce. And nobody can agree on why. But that's not even the part that worries them. Here is what quantum tunneling actually means when you take it seriously at stellar scale. Tunneling is probabilistic. A proton doesn't tunnel every time. It tunnels based on odds, quantum probabilities set by the fundamental constants of the universe. The fine structure constant, the strong nuclear force, the mass of a proton itself. If any of those numbers were even fractionally different, not different in the deep history of the universe, but different right now in this specific region of space, the tunneling rate changes. TRAPPIST-1's excess output is roughly 0.3%. That sounds like noise. It is not. The signal has persisted across 6 years of observation, 3 separate instrument arrays, and 2 independent research groups. What it looks like, and what the Liege team was careful not to say in their published paper, but said clearly in the Q&A afterward, is a localized shift in quantum tunneling probability. Not a stellar anomaly, not an instrument error. A region of space where the laws of physics are measurably different than they are here. And TRAPPIST-1 has 7 planets inside that region. Think about what that means. If the tunneling rate is elevated there, fusion burns faster. A star projected to live another 4 trillion years may be approaching exhaustion sooner than any model predicted. The habitable zone calculations for TRAPPIST-1e, the planet researchers gave the highest odds for liquid water, for stable atmosphere, for life. Those calculations assume constant stellar output. They assume the tunneling rate never shifts. If it has shifted, everything moves. The zone drifts, the surface heats, the water evaporates. We are watching this happen in real time with instruments precise enough to measure it but powerless to explain it. We can tell you exactly what TRAPPIST-1 is doing. We cannot tell you the one thing that matters, whether the shift is accelerating, whether this is a local fluctuation that self-corrects, or whether this region of altered quantum law is expanding, slowly, silently, and in our direction. We have no instrument that detects a boundary like that before it arrives. We would not know until the tunneling rate here begins to change. And at the bottom of every paper on TRAPPIST-1's anomalous energy, beneath every careful word and every hedged conclusion, sits a question nobody has answered. Whether it already has. If the constants can shift there, why not here? Drop what you think is happening in the comments.